Welcome everyone again for Module 3, Part 5 of System Verilog Interface and Verification Examples. So we'll be discussing here the code coverage and functional coverage in System Verilog, and this will be the last part of interface in System Verilog. So this is the last part of Module 3. To understand code coverage, let's take this slide and let's try to understand what is code coverage. So it's code coverage in System Verilog is a metric which is used to determine how much of your code has been exercised during simulation. It helps you to understand how thoroughly your tests are verified in the design. It's a key part of functional simulation and is often used in combination with functional coverage. Now, there are various types of code coverages, and one such the basic code coverage which one should understand or one should know is the line coverage, which measures whether each line of code has been executed. Example, if you have a conditional statement with two branches, line coverage only checks if the lines were executed, not both branches. It will just check whether the lines are executed. Coming to the next type of coverage, it's toggle coverage, which checks if each bit of a register or wire toggles from 0 to 1 and from 1 to 0. Useful for ensuring all signals are actively changing. The third is branch coverage, which measures whether each branch of control statements, like if, case, for, etc., has been exercised. Ensures all decision points are tested. Conditional coverage, which ensures all Boolean sub-expressions in a decision have been evaluated to both true and false. Lastly, we have finite state machine coverage, which tracks state transitions and state occupancy, whether all the transitions have been covered. Ensures all states and transitions are exercised. Now, how do we enable code coverage? There are tools like Synopsys, Cadence, or MentorQuesta, which enables code coverage during the simulation process. Similarly, we have functional coverage. Now, unlike code coverage, which is structured and automated, functional coverage is not automated, but it has to be explicitly defined by the verification engineer. So it measures how much of the intended functionality of a design has been exercised by the test bench. So it covers or keeps the track of important features, scenarios, or corner cases of your design. So why functional coverage? Functional coverage helps answer, have all critical features or scenarios been tested? Are there any untested combinations of inputs or sequences? Are we meeting our verification goal? So these questions will be answered by functional coverage. So functional coverage constructs in System Verilog are, there are two main constructs. One is called the cover group. The other is called the cover point and cross coverage. So how do we define them and how do we instantiate them? Let's see here. So cover groups specify functional coverage points and crosses for a verification plan for driving metrics. So coverage definition is cover group followed with CG underscore group, which is the name of the cover group here. Then you mention your definition of cover group. Generally, in the definition of cover group, we'll be we'll be covering the number of bins for each variable of your DUT, like how many different combinations our variable needs. So we create bins for these variables, and we'll see whether all these bins are being touched by the test cases. Okay, so let's see with an example and understand this. Then end group. Now, how you can place these cover groups inside a module or inside a named block, wherever it's required, you can just place it. And how do you create an instance of a cover group? You have to just call the constructor new. Okay, so for this particular cover group, CG underscore group, I'll just assign it to the constructor new. So in that way, I'm creating an instance of that cover group. Let's see an example and understand how they are used in our code. For example, here I want to design a DUT for, maybe I have a data, which is a 4-bit data. This is a variable. And I have one more 1-bit data, which is valid. Then it also has a clock input. So these are declared in my module. Then for the clock, I will generate an infinite loop using always and generate the clock signal. So this is what in my code I have generated a clock signal for uh, 5 time units. Every 5 time units it toggles, meaning a clock period of 10 time units I have designed. Here now I'm mentioning my cover group for this particular module or for the duty which I have mentioned here. So cover group with the cover group name CG. Then I have to mention inside cover point all the variables and their associated bins. For example, my first variable I'm defining it as data because that's the variable here. So that is in the cover point now. Now this data is a 4-bit data. So 4-bit data will have 2 raised to 4 different combinations. Now, which is equal to 16 different combinations. Now I'm creating bins for these 16 combinations. So bin low covers values between 0 to 3. Bins mid covers a value between 4 to 11, and bins high covers the value between 12 to 15. That's what I've done. If you don't want these classifications of bins, then you can directly go for bins and mention all the values in one bin. Okay, but here I've just segregated it as it's like I'm sending a low packet, a large packet, and a medium packet, something like that. So these are my bins which are used for my variable data. And since it's 16 combinations I can have for this variable, I've created 3 bins and I've fitted these 16 combinations in all the 3 bins across all the 3 bins. Then I have one more cover point because I have valid here. So even that needs a cover point. So cover point valid, if I do not mention the bin for valid, by default it generates bin, and here it's a 1-bit data, and hence it generates a bin of 2 values, 0 and 1. Then I cross all the variables using the syntax cross. I have 2 variables in the cover point, so I mentioned that as data comma valid in the cross. And end group, this is how you write the cover group for this particular DUT. Then you instantiate the cover group using new constructor, so CG and then the instance COV, which is equal to new. So instance of cover group is being created. Then in the stimulus block, what we do is we generate 10 different test cases in this example. For every passage of clock, 10 different test cases. Each of the test case will be generated for every passage of clock. Random test cases. So maybe for the first time, this generated a value 2. So bin low gets a hit, correct? Because value 2 is covered in bin low, so it gets a hit. Maybe for the second time, it generated a value 14. So bins high gets a hit. And maybe for the third time, it generates a value 9. So now bins mid gets a hit. So like that, for 10 different values are generated because it's a repeat of 10. And one of the value in among the 3 bins get a hit. Okay, depending upon what value is generated. And same way, I'm randomly generating a value for valid in a range 0 to 1. So that's the syntax. And during this random number generations, what happens here is I'm also invoking the task sample, which is the built-in function for cover group. What this does is it records the number of test cases being executed or being generated. So it keeps a record of that. And based on how many hits have happened, for the given bins, it calculates the percentage of hits, total coverage actually. For example, if among the 16 different values and among the 2 different values of valid, so I have 18 plus 2, right? For valid, 18 unique values I should get. So if this repeat of 10 gives me 18 different unique values, of course now I've given here only 10, so I will not get 18 different unique values because I just come out of the loop when I finish 10. So my coverage will not be 100%. If I give a value equal to 18 or greater than 18, possibility that I get all the combinations for data and valid is possible. and then I'll be hitting all the cases in the bin, all the 18 cases, and then my coverage will be 100%. So hope you understood. Okay, so cov.sample keeps a track about how many hits have happened, and based on so many hits, it will calculate the percentage coverage. Okay, and so using the get underscore coverage, I can print the coverage value on the screen. So let's understand how we can do that using the EDA playground, which I'm just showing here the code which is being executed. So I have just copy pasted the same code which I just now explained. So when I run this code, I will see what is the coverage which has happened for this particular code. So the coverage is, I could see here, the coverage is 94.44%. The reason being, I'm generating the test cases for 10 times, repeat of 10. So what if I make it 20? So I said there are unique values of 18 need to be generated, 16 for data and 2 for valid. So if I take little more than 18 and see what will be my coverage, it should obviously be more than 94.4%. It may also be 100. Let's see. So the coverage is 100%. So this is how, based on how many test cases you're generating and how it is matching with the hits of the bin, so much will be the percentage of coverage that happens for your DUT under simulation. Okay, so that's about cover groups, which is used for functional coverage. Thank you very much. Actually, yeah, hi. Actually, I thought ADA Playground was getting displayed when I was executing that code. So I'm just again showing this execution. So this code, which I explained, I have just copy pasted on ADA Playground and I'm just executing it. Maybe the code which I explained had repeat of 10 in the beginning. So let me change this to 10 and see what is the functional coverage that gets displayed. So it is, yeah, just see here, it's 94.44 as I said. That's the coverage. So now if I change this to 15, let's see what happens. The coverage obviously will increase. So let's see from 94.44, what is the coverage increase that takes place? So it's again 94.44. So we'll just see that what happens if I change it to 20 and run this code again. Yeah, see, coverage is 100%. So as in how I increase the test cases, the coverage increases. So for example, say I'll just take 3 very less test cases to understand the coverage. So repeat of 3. That gives a coverage of 50%. So it works that way. So the functional coverage will see how many hits happen in each of the bins, and based on the number of hits, which is directly mapped to the test cases being generated, functional coverage is calculated. The percentage of functional coverage will be calculated. Yeah. So that's about code coverage and functional coverage in System Verilog. Thank you very much.